Happy holidays, listener. We have a special episode for you this week. Some old friends joined the show for a 3D printing special with Alex.
Well, I'm joined today by a couple of special guests, longtime JB friends and former colleagues, I suppose. We've got Cheese on the line. Hey, Cheese, how you doing?
Hey, how's it going?
And Drew.
Hello.
Both of you are now in Colorado. You're both in Denver, serendipitously, I suppose. Cheese, you're working for System 76 these days. And what about you, Drew?
I am working for the community college system. So we handle basically high-end IT and server needs for 13 different colleges across the state.
And you do chew my ear off about OpenShift on occasion.
Every now and then, yeah.
It has been known. What about you, Cheese? What are you doing for System 76?
Right now, I'm working with the marketing department, doing videography, photography, some animation, graphic design stuff, all sorts of fun, cool things.
I feel like breaking out into Troy McClure at this point. You may remember Cheese from shows such as the Friday Stream and all sorts of other Linux Unplugged, all sorts of stuff. If you're a long-time JB listener, these two guys will be very familiar to you. So I've got these two today to talk to you all about 3D printing. This is a topic that we covered very briefly in an episode of Self-Hosted recently, and lots of feedback came my way that you'd like a bit more information. So I have two guys that are at different points in their 3D printing journey. So just very quickly, Drew, perhaps you could give us a very quick overview of where you're at in your journey and that kind of thing.
Sure. So just a few months ago, I purchased my first 3D printer and have been kind of getting up to speed since then. It's a smaller unit. It's we'll talk more about the actual gear a little later, but it's a very much the beginner's entrance style unit that one might pick up. It's not super fancy.
So you're looking at this discussion through the lens of someone that's been printing for a few months. And what about you, Cheese? Where are you at in your journey?
Well, I've been printing now for a couple of years. After encouragement, I believe it was from Linux Fest Northwest, where we all met up and you had printed some things, which encouraged me just to bite the bullet and buy a printer. And so I've been using basically the same printer as Drew for quite some time, and over the last couple of years, and learned that I enjoyed the hobby. So want to expand that and picked up a new printer recently.
Yeah, I think I 3D printed a carabiner clip to hold my luggage together or something.
Yeah, I believe it was that, and you had also printed the on-air signs that were powered by the
that's right, yeah,
the little Node MCUs.
Those things are so cool.
Yeah, I think that's what pushed me over the edge.
Well, I'm glad you like them. Of course, they're running WLED, so I hope you've been keeping them up to date. There's lots of new features on that stuff these days. On the ESP side of things. I mean, so I've been 3D printing a little bit off and on for 4, I guess, years. Quite a long time, I guess. I got into it through wanting to print little parts for my racing drones. The perfect use case for me was to print custom holders for all the little tiny circuit boards that go into an FPV racing drone. And so I learned very basic CAD skills, computer-aided design skills, through stuff like Tinkercad and Fusion 360. I am not very good, but I can 3D print a cube or a little square box I made for something easily enough. And so I've had probably 3 or 4 printers. I think I'm on my 4th printer now. I've had some of the cheap Chinese ones, and I've got Prusa's these days, but we'll come on to that stuff a bit more later. But first of all, I thought it might be helpful to sort of talk about what is 3D printing a little bit for those that aren't familiar with it. Would either of you two like to take that mantle?
I feel like as the junior here, that you as the senior printer should take that, but...
All right, fine. Okay, so what we call 3D printing is actually technically probably referred to. It's a bit like calling a Docker container a container and Linux container. Like it's that whole Kleenex debate, right? So what we're actually talking about is what's called FDM printing, fused deposition modeling. And essentially what that does is it takes a spool of plastic filament. It can be of different materials. So there's 3 main types that I print with. I'll come on to those in a moment. But essentially what FDM printing does is it takes in a spaghetti-sized piece of plastic forces it through what's called a hot end, melts that plastic at 220-ish Celsius. It varies on the different filament that you use, the chemical properties of that filament. So it takes that filament in through a drive gear, squishes it through the hot end, melts it, and then the pressure of the drive gears forcing that filament through forces it out of what's called a nozzle at the bottom of your hot end. And so the hot end is the thing that contains the thermistor, and it's what contains the chamber where the melted plastic is and all that kind of stuff. And right at the very end of the process is the nozzle, which is what, if you've ever watched a video of a 3D printer printing, it's that kind of nozzle-shaped thing, funnel-shaped thing on the bottom where the plastic actually gets extruded out of. And essentially, the basic premise is you can use what's called G-code to move stepper motors left and right, up and down, forwards and backwards. You can use G-code to control the movement of that nozzle such that it will form layers of plastic. We're talking an extruded line of plastic will be 0.5 millimeter wide, 1 millimeter wide at most. And what it will do is it will build up layer upon layer upon layer of plastic to form models. It has some limitations. Obviously, you can't print stuff with certain overhangs in certain shapes because the layer by layer construction of these things presupposes that there is a support underneath. So there's all sorts of different ways you can get around that by including supports in your models and things like that. But ultimately, there are some shapes that just aren't very well suited to 3D printing. A complete sphere would be quite tricky because it wouldn't be able to stick to what's called the print bed. And so one of the most difficult parts of 3D printing, which I'm sure both of you can attest to, is that first layer adhesion.
Definitely. I know whenever I first started, layer adhesion was definitely a thing for me. I was using the inexpensive removable bed that came with my printer and quickly found out that probably wasn't the best idea, especially after cracking off one print and then kind of putting a crease in part of the removable bed.
Well, you're doing better than me. I had a Creality CR10 as my first printer, and I went to IKEA and purchased a mirror tile, which is, I think, about 12 inches square. And I actually had something stick to the glass so hard that when I was trying to unstick and unpeel this damn thing, that the print actually smashed the mirror when I was...
Wow.
I took a chunk of glass with it.
That's impressive. Yeah, I mean, I was able to get mine leveled out pretty good, but I definitely had to go to a glass bed.
So even with the original mat that came with my Ender 3, I honestly didn't have many adhesion problems with PLA, which, we'll get into the types of plastics that you can use, but PLA I had no trouble with. It's when I started going on to more exotic filaments that I'm using now that I really started having adhesion problems. And fortunately, I was finally able to suss them out, but it's taken some time and a lot of experimentation to get there.
It does. I think we should dispel the myth right now that 3D printing is out of the box, ready to go hobby. It's not like you can go to Best Buy and buy a 3D printer like you could, a paper printer, for want of a better word, and just press go and expect it to work first time every time. That's just not the reality. They are very finely toleranced machines. We're talking microns of a millimeter makes a big difference to how well a layer sticks or doesn't. A few particles of dust can make the difference between a print sticking or not.
Well, and it's not just that. There are so many different things that can really matter here, like the temperature that you have the filament coming out at, the temperature that you have the bed sitting at, whether or not it's in an enclosure, depending on what type of material it is. There are so many different variables that you can mess up and just totally throw off the whole thing.
All right, so let's break down the filaments for a second. We mentioned PLA. That's probably the most beginner-friendly one that's available, and probably the most popular, to be honest. PLA has a few interesting characteristics. First of all, it's very easy to work with. There's very little in the way of stringing. It doesn't require a particularly sticky bed in order to adhere properly, but it can be quite brittle. So for stuff like my racing drone parts, for example, when it got a bit cold outside, I'd slam my drone into a tree or something, and the stuff would just snap. It would just crack. So It's good for sort of indoor stuff like plant pots, or, I've got a rocket lamp behind me that I 3D printed, for example, so a Saturn V rocket. It's good for that kind of stuff where there's very little load and very little stress on the print. But if you're wanting to do anything where heat is an issue, let's say you're printing a bracket for your car, another 3D print I've done, a functional print, is a dash cam bracket for my car. And, a car in the south of the United States gets pretty warm in the summer. I'm talking to a Texan. I'm well aware that you guys get warm too. But you know what I'm saying, right? If you were to try and use PLA in that environment, very quickly that plastic would get to what it's called its glass transition point and start softening drastically. And eventually, if it's under any kind of load, even if it's just from a dash cam, a few grams, it would start to warp and twist and eventually melt.
Yeah, and I think that depends on your print too, because a print that I'd made for some friends, they had an above ground pool, and on that pool was a railing that, I don't know, what the diameter of that railing, but they had no cup holders, right? So everyone was trying to figure out, like, where do I set my drink down? So I made some cup holders, and it just had these little hooks that hooked over the top of the ring on the pool, and was able to, put your drink there. And they probably sat out there for a little over a year before one of them finally failed. And one of the little arms had cracked. And I don't know if that's because somebody bumped it or how it happened, but it can hold up to some extent, but under a magnified windshield in the heat, direct heat, probably not the best.
Yeah, there's no chances there. So for that kind of application, you want to be looking at something called PETG. There are a few other types that are suitable for sort of higher temperature environments, but PETG in particular is one of my go-tos. It's sort of chemically related to PLA, so it takes the best bits of PLA and another plastic called ABS, which is famously difficult to print and work with because of things like warping, which is where during a print, the corners of a print will lift and then the entire model is put under intense stress and it can start to crack and all that kind of stuff. But PETG is probably the best of both worlds. It's got pretty much the same ease of printing as PLA and almost the same heat-resistant characteristics as ABS. The downside to PETG is it can be a very sticky thing indeed. That was the filament that stuck to my glass bed and took a chunk of glass with it, for example. So chemically, it's very good at bonding with the build layer, the build surface on certain printers. So for my Prusa behind me, for example, I actually have two separate sheets. I have a textured sheet from Prusa, which is actually designed for PETG, and a separate one for PLA, just so that I have that separation of concerns. I don't have to worry about glue sticks or any other kind of nonsense or tape or anything like that.
It's worth mentioning, too, that PETG is the slightly more exotic material I referenced earlier that I was moving towards and was having adhesion issues. It does require more heat than PLA to really get it to flow nicely. And you also can't print as fast because, to get it to where it's flowing well, if you get it flowing too well, then it bubbles and there's, you need a hotter bed to really get it to stick well. And it's a lot more finicky, but not as finicky as something like ABS or anything like that.
Yeah. So we're talking about with PLA, for example, that prints, the nozzle is around, or the hot end, is around 180 Celsius. And typically I run my bed at around 60 Celsius. With PETG, I can run my hot end anywhere from 220 to 250, depending on the particular filament properties. And the bed is anywhere from 80 to 90 degrees Celsius. So there's a good step up there in the temperature and therefore energy required to use this filament. But that's why it performs better in, heat-sensitive environments.
Speaking of, different filaments from different manufacturers can have vastly different responses. Like I'm using various filaments from Micro Center, and I have my bed turned up to about 100. I find it works a little better, but I can print with the PETG itself down at about 230, which is the low end of what Micro Center actually recommends for that filament. Really, it just depends.
Yeah, most manufacturers will print a recommended set of settings on the side, and that's generally a good place to start. But you will need to start printing things like calibration cubes and, temperature towers and torture tests and all this kind of thing if you're moving to a completely new supplier of filament and you're not seeing the results you would expect. There's all sorts of things on a website called Thingiverse that you can actually download for free to import into your printer's slicer software and send across to the printer. So speaking of slicers, Cheese, we haven't really touched on that much at all yet. Would you like to?
Yeah, so a slicer is basically exactly what it sounds like. As Alex had mentioned earlier, with FDM, you're laying down layer by layer. So a slicer will take your 3D model and separate it layer by layer, drawing the path and or creating the G code that allows the printer to know in X, Y, and Z in space where the nozzle needs to be at any given time. And then once you've taken your model and you've sliced it, then you can import that G code directly into your printer and print your model. So there are a couple of different pieces of software. Cura, which is one that I'm a little more familiar with. That's Cura. It's really great. And then Prusa, the manufacturer of 3D printers, actually has their own piece of software. I think it's a fork of Slicer. Was the original name, and now it's just referred to as Prusa Slicer. But it's kind of the de facto for them.
Spelled Slick 3R if you're looking for that on the internet.
Slick 3R. Yeah, that's it. It's Leet Speak spelt, right? But yeah, it's a great one as well, and I'm learning more of that now that I've purchased a Prusa printer. But Cura is also fantastic, and there are a lot of settings that you can take from other resources. So I know Chep is one of the guys I took his settings for Cura originally, and they worked really well for me, better than the stock settings that were suggested by Cura itself. So
I'm pretty curious to know how the humidity has affected you, because I know you've just moved from Texas to Colorado, and obviously there's a drastic humidity difference between the Gulf Coast and the Colorado air, and PETG is famously hygroscopic. So what that means is it will absorb water from the air around it. So me and Raleigh, for example, with my relatively high humidity, I have to keep my filament in a dry box full of silica gel in order to try and keep it relatively usable. I was wondering, have you noticed any difference in how you store your filaments and how easily they print or not at the different altitudes and humidity levels?
Well, for me, I haven't really experimented with much outside of PLA. So I know the PETG, like you said, has a lot more, is hygroscopic, as you mentioned. But I will say that with PLA, I have noticed that moving from Texas along the Gulf Coast to here in Colorado, even the PLA, it gets more brittle than normal. So it's not like I keep it in a humidifier or something, but once I get through the batch of filament that I have now and I move over to PETG, I'll know a little bit more. But so far, the humidity and the change in humidity has affected the PLA, but not significantly to the point where I can't print with what I have. So,
how about you, Drew? How's your experience been?
So, I've only been doing this a few months. I'm not sure how quickly PETG, under circumstances like yours, Alex, would really take on enough water to need to be dried before printing, but
could be a month. It could be 3 or 4 months. I mean, it really depends. Like, for example, you were living in Georgia before,
yes,
and now you're in Colorado.
Right.
Similar thing as Cheese, really. An ocean level of Gulf humidity moving up to the mountains. So
right. So here, I have had my PETG sitting out for a while, and I keep it in a box most of the time, but I don't after a print is finished, heat up the end and pull the filament and put it back in the box. I tend to just kind of leave it on the roll.
You should be fine where you are now. I mean, I was wondering whether you'd noticed any difference in terms of how, because I know, for example, things like boiling a kettle takes longer at altitude, right, and, baking recipes are slightly different.
Yeah, exactly. So, no, I haven't had any issues just leaving my PETG on the roll for weeks. Still prints fine.
All right. Well, talking of software, we mentioned Prusa Slicer and Cura. Those are the two main slicers. There's another piece of software that I think everybody ought to know about called OctoPrint.
Wonderful piece of software.
It's like the best thing.
Wonderful.
Seriously, if you are getting into 3D printing, just, do yourself a favor and Google OctoPrint. It is something that you install on like a Raspberry Pi, and you connect it to your printer via the USB slot, and then you can control your printer remotely. It is damn near necessary for anybody who's really going to do this as a hobby. You really need a way to be able to touch your printer without having to walk to it.
Absolutely.
I totally agree. I have a Pi 4 running my OctoPi instance. So the piece of software is called OctoPrint, but the developer of OctoPrint makes available a build for the Raspberry Pi called OctoPi, making the Raspberry Pi ecosystem almost synonymous with 3D printing, in my opinion. And I actually use that to run the Python application, which is OctoPrint. There are a bunch of different plugins you can get. So, for example, I have one that's called Spaghetti Detective, which looks at my webcam feed and tries to use machine learning to try and figure out if my print has come unstuck for any reason. That's a fun one. There's another one that does Telegram integrations, so I get notifications and I can control my printer via Telegram bot. I can get GIFs as well, all that kind of stuff. There are hundreds of plugins. We couldn't possibly list them all. MQTT is another one.
Yeah, MQTT is awesome. The time-lapse plugins.
Yes, that one is great.
The webcam plugin, just in general, to let you monitor in real time. There's even cost estimation plugins. So based on the G-code that you provided, it will estimate how many grams of filament and how much that filament costs, and therefore how much a print's going to cost. So there are a lot of things in OctoPrint that there's really nothing out there that compares to it that I've seen. And it's probably one of the best uses for a Raspberry Pi, especially if you have, well, specifically if you have a 3D printer.
For sure. Now, I would probably suggest running it on a Pi 4. I've been running it on a Pi 3B Plus for a year or two, but I upgraded about 6 months ago to a Pi 4, and it's night and day difference. It's so much faster, and I would highly recommend a Pi 4 as a baseline if you're just getting into this.
So a few months ago, everybody from JB came out to Denver, and we all had a jolly good time, but Linode was giving away Raspberry Pis at our little meetup, and I managed to win one, right? So
yeah, you did.
That's what my Raspberry Pi from Linode is doing. So
awesome.
Rad.
So the final filament I think's worth talking about is TPU, which is a flexible filament. Have either of you experimented at all with flexies?
Not yet. Looking forward to it, though, but not quite yet.
Yeah.
It's a world of pain.
Not at all. I mean, I'm familiar with TPU in that, I've purchased phone cases before, but as far as actually making it myself, no, I haven't.
So with the Creality CR10 I used to have in London, I was printing a lot of drone parts, as I said, which included stuff like GoPro mounts. Like I say, when I smashed into a tree, I wanted some give in the part, so it didn't just smash into 1,000 pieces. And with the CR10, it had what's called a Bowden tube extruder, which essentially means that the gearing which feeds the filament into the hot end is on the main body of the printer connected to the extruder via a plastic, nylon tube. Whereas the Prusa has what's called a direct drive extruder. And I've had a lot of success 3D printing with the flexible filaments on the Prusa simply because there's a lot less chance for a flexible filament to kind of collapse on itself and start tying itself in knots like spaghetti on the direct drive printers.
Yeah, I haven't had much experience, actually no experience with TPU yet, but from what I've heard, the direct drive is kind of the way to go for that, because and depending on the extruder itself, right, the extruder itself can have one gear or multiple gears in it. So with multiple gears, you're able to pull filaments that are maybe a little bit more difficult to pull through the hot end and out the nozzle. So I'm looking forward to it. I kind of want to print my own phone case, but we'll see. I don't want to buy a whole roll and then just be sad because I can't print with it and now I have a whole roll of TPU.
One thing I will say is TPU is incredibly hygroscopic, so just bear that in mind. There are some more exotic filaments, there's carbon fiber-based ones, but once you start getting out of those main three that we talked about, so PLA, PETG, and TPU, once you go outside of those three mainstream ones, there are significant compromises to be made with all the different other plastics that are available. There are too many for us to get into today, but that's an overview of most entry-level filaments for most beginners.
Linode.com/SSH. Go there to get $100 and 60-day credit on a new account. And you go there to support the show. What I love about Linode, straight up, it's fast, reliable cloud hosting. And you should really go try it for your next project. It also makes for great R&D if you want to learn something and spin it up super quick. I guess back in the day, I used to fuss a lot more with VMs on my workstation. But these days, I just jump on the Linode dashboard and I get it going in no time. And one of the things I love is when I'm setting up a system, you can actually get console access through an SSH session. They even just give you the command right there in the dashboard. You highlight that, copy that thing, paste it into your terminal. You hit that sucker in, and then you're actually like in an SSH session looking at the console of your Linode machine. It's awesome. It's just those kinds of things that make it fun for when you really want to get down deep, but they also have like the one-click deployments of stuff. Like maybe you want to do a GitLab. Maybe your own Jitsi server. Get rid of that Zoom. One-click deployments for that kind of stuff. And they've been rolling out PCIe NVMe storage, so things are real nice and fast. And they have 11 data centers around the world, so you're going to find something close to you or your clients or whoever you want it to be close to, because there's 11 of them. And Linode's been doing this for 18 years, and they just keep dialing it in and making it better and better. So go see it for yourself. Use it for your next project, deploy something, maybe run a game server up there. Go have fun and use our promo code and get $100. It's linode.com/SSH.
So then there's a question about, do I need an enclosure to 3D print? And the answer is maybe. I mean, there are a lot of factors that kind of go into it, but the main one is, do you need to really contain the heat, for one? And two, are there environmental variables in the area that you're going to put your 3D printer that you might benefit from using an enclosure? And in my particular case, I have lots of pets with lots of loose fur. And that was the primary reason that I bought one. I'm pretty sure it's saved a number of my prints already.
Yeah, I mean, there's lots of cases I've had where just, a single corner has lifted on a print for no discernibly good reason, and then I realized that the air conditioning kicked on halfway through that print, and I'm like, I wonder if that draft from that vent up there was just enough to cause that part to cool down, just enough to lift or something. So yeah, like you say, it's highly dependent on your environment. It's also highly dependent on the plastic that you're using. So some plastics give off odors and smells, and sometimes you might want to actually extract those fumes away from the printer from the enclosure. But generally speaking, most people run an enclosure to prevent, like you do, pet hair or dust, or to maintain some kind of temperature for more finicky plastics like ABS.
I could see it being really valuable to have your printer in an enclosure if, say, you had your printer in your garage and the ambient temperature of your garage may shoot down during the winter, or, different variables just in the area in which your printer is. So I can see there being, some uses other than just to help maintain the dust and noise and fumes of a printer. So
yeah, totally agree. Garage is a great shout, particularly in a garage as well. You're going to end up with a lot of environmental debris in there because they're not as well sealed as a house, for example. So, all right, should we take a few moments to discuss the various different printers that we all have and the gear that we've got?
Yeah, let's do it.
Drew, would you like to go first?
Sure, as the newbie here. So I bought an Ender 3 Pro, which I then very quickly upgraded various parts of. One thing that I saw on the Ender 3 subreddit that I really, really enjoy is that when you buy an Ender, you're not buying a 3D printer, you're buying a do-it-yourself 3D printing kit.
Yes, you are.
Yes.
And that is absolutely so true. I have replaced a number of things on my printer already. I went from the Bowden tube setup to a direct drive, And I've also replaced the original hot end with an all-metal one, which is to say the original one had a piece of plastic tubing that goes all the way down almost to the nozzle to feed the filament. And the one I replaced it with has a fully metal body so that you don't have the issue of, if you print it too high of a temperature, that tubing starts melting inside the hot end, which can happen once you start getting into things like PETG. So I just didn't want to deal with that. I went ahead and upgraded to the direct drive. I've also upgraded to what's called auto bed leveling. So with a normal 3D printer out of the box, typically, at least for the lower end ones, you have to manually go down there and measure down to the millimeter every corner and adjust the height so that it is the same distance from the nozzle all across the whole bed.
Potentially every single time you print as well.
Exactly.
Yes.
Yeah.
Sometimes the vibrations of the previous print cause your calibrations to be off. It was just, I mentioned I had a CR10 in London, which I sold before I moved to America. And that had manual bed leveling on it. And it was just the most frustrating thing in the world. You didn't know if it was going to work until the first layer was all completely done.
Right. Yeah. So now with the auto bed leveling, it literally will, before a print, go through and take measurements in 9 different spots. And you can tune that depending on the firmware you're running. But on mine, it's 9 different spots across the bed, saves that value, and then when it goes to print, it pulls that value up, shows itself a mesh, and says, okay, this area is a little lower, so I need to compensate for that. This area is a little higher, need to compensate for that. And so it takes something that's not level and essentially adjusts itself to make it level. One of the best upgrades.
So you have just outlined my primary argument for not buying an Ender. Very, very eloquently, and I appreciate the fact that you did. I'm curious to know, how much did you spend on it in the first place, and then how much did you spend on upgrades?
Yeah, I'm curious.
So the original Ender I found on clearance at Micro Center for $200.
That's a great price.
Yes, it is. So I snapped that up, and then the upgrade kit with the auto bed leveling, and it also had the silent board, which is the upgraded V2 board, as well as the V2 screen, which the V2 is the next version up from the Ender 3 Pro. So I got all of that for under $100. And then the direct drive was about $60. The all metal hot end was about $40. And then I also replaced the cheap brass nozzles that typically are the things that come with it and that most people buy in like packets of 20 because they wear out after like 3 prints, in my opinion. I replaced that most recently with a Nozzle X, which the nozzle alone was $40. So far, it is worth every penny. I'm 60% through my first print with it, and it has had no issues so far. Fingers crossed it's going to be a great upgrade that outlasts the actual printer. So all in, I mean, we're talking, less than $500?
Mm-hmm.
Yeah, probably around $400 or so.
Yeah, and I feel like I've got a really good machine going now.
Those are some solid bargains, dude.
Mm-hmm.
I think the next time I want to buy something off, from Goodwill or something on clearance or Micro Center, I'm going to deploy Drew to go and find it for me.
That's right.
Dealhound Drew. Find any 3D printers wherever you go.
That's right.
I like it. To be honest, though, Drew, I think that's probably about the same that I have into my Ender. Somewhere sub $500, I would say.
So you went with an Ender as well, did you, Cheese?
Yeah, I went with the Ender 3, the Ender 3 Pro. Basically the same printer as Drew. I got it for $180-ish on sale through Creality. Good deal. I think they're wonderful printers if you enjoy tinkering, you don't mind assembling it, you don't mind adjusting it to get it all dialed in, and you don't mind incrementally upgrading it.
I think that's particularly interesting because I know that you've just bought yourself a Prusa.
Yes.
Which is something I'm a huge fan of. And I'm really curious to get your take as someone, besides me that's just used both an entry level now and what is considered the Rolls Royce of FDM printers, the Prusa i3 Mark III. I'm curious to know what you think now you've used both.
I think there's a place for both. I think the Ender's great to get started on and see if you like the hobby. And then I think most people find themselves looking at Prusa or other high-end 3D printer manufacturers for something that is more just kind of turnkey and reliable.
Yeah, 100%.
And that's definitely what I've gotten with the Prusa. So,
well, let's not forget as well that the Prusas are $750 as a kit and $1,000 pre-built. So they're twice the price.
They are twice the price. I just splurged and bought the $1,000 kit, the pre-assembled kit. It came in, obviously pre-assembled.
See, I have strong opinions about this as well. I think that everybody that's buying a Prusa should, if they have the time and the means, should go through the process of building it. Because the first time I built a Prusa, I've built two now, I learned so much about electronics, about how different screws fit through different things, and just quite what 3D printing's capable of in terms of part tolerances and the strength of different pillars and all that kind of stuff that's required. Highly fascinating procedure. Yeah,
I mean, I think it's worth doing that. I'm not against that. But I felt that I had kind of already done that with the Ender.
And I can see that.
When I had gotten to the point where I wanted, because I generally don't purchase things like this for myself, or I wanted to have something that was turnkey, right? So I just wanted to pull it out of the box, set it on the table, plug it in, go through the initial setup. Some of the things that you get with the Prusa that you don't get with, say, an Ender. The Prusa comes with a handbook that goes through everything you need to know about the printer.
It's about as thick as a Bible. It's amazing.
Yeah, it's a great handbook, great documentation. Not that you can't find great documentation for an Ender or something like that. Probably not through the vendor, more so through third parties, but there's documentation available there.
Prusa sets the bar, in my opinion, for documentation, for customer support, and also, not to come across as too much of a fanboy, but everything they do is open source. The hardware designs, the drawings, everything is open hardware. It's all based off the original RepRap movement. It's all designed around 3D printers printing more 3D printers.
Correct.
Which is kind of it's machines making machines. So Matrix, watch out. But in my opinion, as a company, Prusa do so much right. They're based out of the Czech Republic in Prague. Josef Prusa is incredibly present on social media. He also does a lot of YouTube stuff. You'll frequently see him on with Joel Telling, who's the 3D printing nerd on YouTube. And, there's so much in my life that is, open source, working for Red Hat, obviously open source is at the core of everything that pays my mortgage. And, it's been a huge factor in my personal journey with Linux and everything else, So the fact that I can also buy a piece of hardware that is totally open, 100% open, and the vendor has shown a commitment to doing everything open for a decade or so now. For me, Prusa is just I'm a fanboy. I'm going to admit it, but Prusa is pretty much untouchable in my opinion.
Yeah, I mean, Prusa does a lot of good things, right? They even have their own prints library, similar to Thingiverse. But in that same vein, the Ender 3 from Creality is open source and open hardware.
Only because of Prusa.
Absolutely. Well, they set a bar, right? But
and it didn't used to be. If I recall correctly, it wasn't open, and then Creality bowed to public pressure and eventually released drawings that were of a questionable quality to start with, and then they've improved with time.
Well, I mean, I don't know about that. I'm not here to bash on Creality, but I'm just saying that they also have open source their hardware, I think that it's good to have someone like Prusa in the market to help push those narratives and to help push the way that things should maybe be conducted in an ecosystem, right? So, by making these things open hardware and encouraging others to do so, I think it's awesome.
I think I look at this through the lens of drone racing, where there's an awful lot of commodity parts put together onto flight controllers and things like that. And Chinese clones are a real problem in that industry. You'll have a lot of guys in the West that put a lot of IP into developing specific, radios and flight control algorithms and all this stuff. And they will put that board out to be made at a factory in China at a decent price. And then 2 weeks later, a complete copy clone of that thing is floating around for half the price on the internet, and for a while, I kind of felt like Creality were in that similar space of just copying IP. They have proven me wrong, I think, in general. They've done a lot of stuff to open source a lot of their drawings and stuff like that, but there's still a way for them to go, I think.
Definitely think there's a way for them to go. I mean, I think there's a way for the entire industry to go as well. And I think, going back to kind of why I had ended up going from Ender to Prusa, the Prusa has a lot of nice features, right? It's got auto bed leveling built in with a really accurate probe. It's got a really nice bed that comes with it. And the steel sheet to put on the bed. And Drew had mentioned earlier that it draws a mesh, essentially. So, mind you, all of these printers, regardless of which one it is, the bed is not going to be manufactured perfectly true. It's basically impossible for that to happen. That's why you see people use mirrors on their 3D printers, is because mirrors are generally more true than a piece of glass. Because if you had a mirror that wasn't true or flat, then you would have a funhouse mirror. And I don't think, everyone wants to wake up in the morning staring at a funhouse version of themselves while they brush their teeth. So, there are a lot of nice features that come with the Prusa. You get, the direct drive extruder, which you can also, love this feature, remove the filament. So instead of, say, with my Ender, I would heat up the hot end and then just yank the filament out. With the Prusa, it will heat up the hot end and then reverse the drive gears in the extruder to pull the filament out. And I just pull the filament out of the top of the extruder.
It's pretty nice.
Super nice, super clean. The steppers and the drivers for the motors or the steppers themselves and the drivers for them are super quiet. I hear the fans more than I hear the motors, which wasn't true. And I'm sure, Drew, you can attest to this, that the original Ender board that you had in your Ender 3, the sound from whenever you upgraded from the original board to the version 2, just the drivers for the motors.
Dude, it's night and day.
Reduced. Absolutely.
Yeah, it's ridiculous how loud the Ender 3 Pro is out of the box.
So let me ask you both, what kind of stuff do you print these days?
So I've been printing lately things like cases and stands for various items that need them around the house, some things for some musical instruments and things of that nature. My wife and I, when we first started getting into 3D printing, part of the goal was to design things, print them, and then use her Cricut maker to print vinyl, which could then be 2D printed to have her designs on them, and then go onto the 3D objects to sell through her store.
That's very cool.
So that's coming. We both need a little more experience with our individual parts. Like, I need to get a little better. I haven't designed anything yet as far as 3D printing is concerned. That's the next level up, right?
That's a whole nother ball game, man.
Absolutely.
I'm getting used to making the filament do what I want it to do before I try to make it do stuff that we're going to sell.
Understandable. Absolutely. For me, I've been printing, shortly after, I would say maybe 4 months after we got our printer, COVID hit. And like many makers of the time, Alex, I know you were one, and had encouraged me to get onto the bandwagon as well, started pitching in and making face mask or shields using our 3D printers and some other materials. So I spent a lot of time doing that, printed a ton of those for schools and nurseries and random public places. But I enjoy printing cases, little electronics projects. I think after seeing your recording sign project, and it also got me kind of into microcontrollers. And I think that 3D printing helped kind of drag me there too. So, like I've printed a little project that has a 0.96 inch OLED screen that basically connects to OctoPrint, tells me the progress of a print. Sits on my desk. It's powered by 5 volts. Just recently finished printing a case for a Stream Deck that I'm planning on making using a Arduino Pro Micro, some sliders, and actually some of the Jade switches that are left over from the launch keyboards. Sometimes in our shipment of switches, we get bent pins. And so we have like a bent pin bucket. So I rated the bent pin bucket and found some switches to include in the project. So
Nice.
Looking forward to getting that one done. But I think as you start with the hobby, you find just, things that you can print online, things that are useful. Then you drift into kind of designing things, and the next thing you know, you're just absolved in it. I guess it's kind of like a drug addiction to some extent, right? Like
maybe a drug addiction would be cheaper at times.
At times, right?
Maybe.
Like maybe. I wouldn't imagine over the long term, right? Maybe short term, but like Drew said, buying the upgrades and upgrading the thing, you just kind of get into this something. I don't know what it is. It's like this thing that just pulls you forward to like, let's make all of the things. How can I just make this myself? Instead of just being a consumer and just grabbing the first thing off the shelf that kind of fits your needs or solves your problem. It's nice to be able to actually make something yourself to solve that problem.
Totally agree. An example of that in my life recently, my daughter recently figured out how to crawl. And so obviously we started needing to baby-proof the house. So I've printed corner protectors for, things like coffee tables and the outlet prong protector things, all sorts of little things like that,
Have you printed any little door locks for like under the cabinet?
No, but I think I will need to pretty soon.
Yeah.
I do a lot of stuff like shelf brackets and little widgets to help me, in the workshop when I'm doing woodworking, that kind of stuff, like little templates and routing guides and that, like jigs, that kind of thing. There's just so many little things you can do with it. There's a great subreddit called r/functional print.
Yes.
And there's all sorts of great stuff on there. So if you're struggling for inspiration, take a look at that subreddit.
Have you guys, on the note of all of these printers, and Alex, I'm sure you guys have, Drew, have you had a chance to see the new Prusa XL printer?
That's a big boy.
I have not. How big is it?
It's XL. I mean, it's not double XL, but it's XL. But it also has automatic extruder tool head changes. So you can have multiple filaments loaded, like I think it's 5 filaments loaded at a time, and it will just pick the head and pull the hot end and
so
head.
Typically a Prusa is 9 inches tall by 8 inches front to back and left to right.
Right.
The Prusa XL is 14 inches square. Just that's its build volume, is front to back, left to right, up, down, 14 inches. So significantly larger. And in order to do that, they're charging $2,000 as a starting point for this printer. Bear in mind, a normal Prusa starts at $750, and they've got the Prusa Mini as well, which starts at $300-400, something like that,
right,
to compete with the Enders. But like Cheese says, the really cool game-changing feature that they've got on this new Prusa XL, it's not just the fact that they're changing the heads or anything; they're changing the whole tool. So it's 5 separate. You can have up to 5 separate extruders on this thing. So you could 3D print 5 completely different materials. So you could have dissolvable filaments, soluble filaments, to do supports, for example, that you could then submerge your print and they would just dissolve. So there's all sorts of really interesting different applications you could use for that one.
And it has a really neat new bed technology, the way that they've segmented the bed. So instead of it just being a flat bed, they've segmented the beds, leaving like cooling and expansion channels in between, so that as the bed heats up and expands and contracts, you'll be less likely to have warpages on the bottom of your prints where they're adhering to the bed and stuff. A lot of cool new tech definitely coming out from Prusa, which I think is going to set the bar for everyone else going forward. And, hopefully we'll continue to do this ourselves, and next year we'll sit down and see where we are. But I did have a couple of questions for you, Alex, and Drew as well. Do you guys weigh your filament before you put a print together? So if you know that you're going to have an extended print, do you weigh the filament that's on the roll before you load it into your printer to make sure you have enough filament, or do you just cross your fingers and hope that you have enough filament?
I do the cross and clench method. Yeah.
Okay.
The Prusa has a filament runout sensor, so I'm not too worried.
Yeah, and my upgrade kit also came with a filament runout sensor, which I haven't actually installed yet. I need to do that, but I also haven't gone through enough filament yet to really make it necessary as of now.
Got you. But I mean, do you weigh your filament? How do you measure to know if you have enough filament on a roll to complete a print? Do you just do the same method, just the cross and clench method?
Yeah, pretty much.
Eyeball it.
Yeah. You're like, that's roughly half a roll. We can roughly get this much out of it.
Well, I haven't gone even through half a roll of any of my individual rolls yet. I've got like 8 different rolls of filament sitting around, and I've kind of played with each of them so far,
If you consider that each roll of filament is a kilo, typically it's a kilogram, that's a lot of plastic. So you'd be printing something pretty massive in order to go through an entire roll in a single print.
Yeah.
I think where it matters more is where you're trying to use up the dregs, for example.
Absolutely. And that's why I'd asked. Yeah.
And I got pretty good when I was doing the mask making that you referenced when COVID first started. Kind of doing like a hot swap. I would sort of sit, printers next to me on my desk. I'd sit and watch it, and then I would have the second spool ready, and I'd just sort of get a lighter and fuse it together really roughly, and then file it down a little bit and sort of show it, and it would be fine. It would jam occasionally, but most of the time it was fine.
I never thought of that. Whilst doing that, I would do the same, but I would just watch OctoPrint and then hit pause.
You could do that. That's probably safer.
And then just swap the filament out.
That's probably safer.
I never thought of. I mean, that's a good way to do it. I mean, I guess you could potentially introduce clogs, but
I could potentially burn my house down. But apart from that,
only the nozzles are only a few cents each if you get the cheap brass ones that Drew had mentioned earlier. What about maintenance? What do you guys do for maintenance on your printers?
There is an excellent video by a Welsh guy on YouTube whose name escapes me, but I'll put a link to it in the show notes, where he talks through dismantling a Prusa, for example, and all the different oils that you need to put on various different parts and what have you. I tend to do it on an annual basis or as often as I can be bothered. It really depends how much you're printing, how many hours a day you're printing, that kind of thing. My printer sits idle much more than it's printing, to be perfectly honest. So I don't feel the need to do quite so much maintenance. But if I was running a print farm or something, I would definitely put it as part of a regular regime.
Gotcha. What about you, Drew? I don't imagine you've done much since you haven't had a printer too long, but what kind of maintenance do you do?
As far as like the printer maintenance that Alex is talking about, I haven't done any. However, once a week or so, if I have an issue that I notice, like there's the x-axis is a little wonky on a print, I'll go through and I'll check the belts. Spot checking various things. One thing I will say is after every print, I will go through with a microfiber cloth and just wipe down the bed, wipe off the nozzle, make sure that everything's clean and ready for the next time I go to print. That is one thing that I would say is well worth doing, is just having something around to just wipe down the bed and wipe down the nozzle at the very least every time you do a print. Just because you can get stuff that maybe attaches to the nozzle, although it's less of a problem if you have one of the nicer nozzles than it is with brass, but still, it's good practice to clean up after yourself in your workspace.
Yeah, and I would say that I do that as well. Every time I have like a little spray bottle of isopropyl alcohol and a microfiber cloth that I just spray down and wipe the bed every time.
Yeah.
Finish with the print.
I used to spray mine down, but now with the PETG, because I am printing on tempered glass, I do use glue stick. So I tend to leave the glue stick. I don't wipe that down after every use. I'll do a number of prints before I go through and wash it off and reapply.
That's one of the beautiful things about the Prusa, though, is I can't remember the last time I cleaned my bed. Maybe that's bad, but it just works every time.
Well, I'm looking forward to that, but I'll probably still clean my bed every single time I print something. It's habit, dude. I just can't not.
I used to, just out of habit from the CR10 that I had, but eventually I just stopped, and it, whilst I was doing the masks, I got pretty good at figuring out what was actually needed versus what the internet told me I needed to do.
Right.
And generally speaking, as long as your house isn't in the desert, full of dust, you should be fine with just the occasional wipe down.
When I say clean, all I really mean is literally taking a microfiber cloth, running it across the bed, running it across the nozzle. Job done, right?
Mm-hmm.
We're not talking about you have to get in there and like scrub every nook and cranny or anything like that. No, it's...
I had to do that on my glass bed with the Creality that I had.
Oh, well...
Take some dish soap and wash it with love and care and affection, and then never touch it and it was just a pain in the ass.
After every print?
Pretty much, yeah.
Oh, God.
Wow.
That's horrible.
Bear in mind, this was like 4 years ago before, things have come on a bit of a way since then.
That's fair, yeah. No, I mean, for anybody listening, if you're getting into it and you want to take my route where you're kind of spending a little less money and doing some DIY upgrades, go get yourself some decent quality glue stick. It makes a world of difference. It really does.
100%. Now, thank you both for joining. I really appreciate you taking the time out of your schedules to come and talk to us today. Is there any way you'd like to send people to follow you or anything?
I mean, you can follow me on Twitter at CheeseBacon. That's CHCBACON. If you have any questions or just want to talk shop, feel free to reach out. My DMs are open.
Yep, same here. Drew of Doom on Twitter. Feel free to reach out.
Well, thank you both very much.
Thank you for having me, man.
Yeah, thank you.
Maybe 2022 will be the year that I finally get a 3D printer. I know my kids would love it. And then I know I'd start printing stuff for my RV all the time. I want to say a special holiday thank you to our members over at selfhosted.show/SRE. You make this show possible. Don't forget you also get the extra post show. And we now, after a lot of, I guess the term is popular demand, as they say, we now have a network membership at Jupiter.party. You can gift it as well. We'll have that for a little bit longer. And also till the end of December, if you sign up, we're taking $2 off. So normally the membership is just the cost of 2 memberships, but you get access to all the show special stuff, all the goodies, the behind the scenes stuff and love, the member stuff that you get only with self-hosted's member show, the Coder QA, all that, and Linux Action News, totally ad-free, and any new content we add as well for just the price of 2 memberships. But right now, until the end of the month of December, we're taking $2 off for a year. This membership is designed to let us be picky, to make sure we choose the right sponsors. We get a lot of emails that come in and, we don't want to be in a position where we have to work with a sponsor that we don't actively believe in. And this lets us be picky. It gives us runway because these good sponsorship deals, they don't happen overnight. They take months to develop a relationship. You give us the runway to do that. The episodes where there's fewer sponsorships, those are the episodes our members actually make possible too. So it's a pretty special thing, and it puts you in the driver's seat because you're funding the content, and that's fundamental. That changes everything. Jupiter.party if you'd like to be a member for the entire network, or selfhosted.show/SRE if you'd like to be a member just for this show. And even if you can't support us through a membership, we are so grateful for your downloads, for your community support, for maybe telling a friend, maybe leaving a review somewhere. So happy holidays from the Self-Hosted team, and feel free to reach out to us at selfhosted.show/contact, and ho, 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 we'll see you right back here next year.